Hey guys, welcome. My name is Prince. I'm an electrical engineer, a firearm electrician, and I'm very elated to bring to you a new topic. Today we'll be talking about the implementation of a single firearm system. However, before we get into that, let me introduce you to my organization, the Virginia Society of Engineers. Our mission is to provide engineering solutions to the wider society and to improve how engineering is practiced. Vigilant Society of Engineers, our objective is to build a platform for networking for electrical engineers to offer engineering solutions via information exchange through pilot projects, seminars, and workshops. So we're going to get into this presentation. Here we got a beautiful view of a fire alarm panel internal circuitry, displaying ports for notification devices and initiating devices that have speaker strobes and smoke monitors. We also have ports for relay, and these can be used to monitor the output of switches or to use for the activation and deactivation of equipment that integrated with fire alarm system. And these ports appear at the top of the panel. At the bottom of the panel, we have the inputs for the fire alarm system. We're showing you the amount of power the panel need to receive. As it indicated, 120 volts AC input, 50 Hertz, 2.3 ampere. By indication, we would expect the same, for the panel. However, some panel may use, different voltage levels. So next we speak about the fire alarm components. These components we speak about are initiating device and notifiers. Initiating devices are devices that sense the fire in the building, or in some case, devices we need to activate the fire alarm system upon seeing fire in the vicinity of a building. The initiated devices of carbon monoxide detectors are devices that will sense smoke, then activate our fire alarm system. The photoelectric detectors has similarities of the carbon monoxide detector. However, this photoelectric detector will pick up and then send a trigger to the fire alarm panel to set it off. The manual call point works a little different. In this case, an input is required from someone who see fire in the air or vicinity and trigger the manual call point. And just the same for the pull station. The pull station can be activated by pulling up a switch or pulling down on a switch where a fire may be at present. Notifiers provide signaling function. A notifier is very important for the occupant to know that there's a fire in the building. The notifier may produce sounds or flashing light. A notifier can be a speaker or a strobe. It may come in the form of a bell, siren, and a telephone may also be a good notifier because it can be used to relay a message through a speaker to allow the occupant to escape the building. Okay, so these components are what we were speaking about, and these are the most common used components: the smoke detector, the manual pull station, and the speaker strobe. So in every building, these are the most commonly used devices, and they're very critical for the operation of the fire alarm system. The fire alarm system wiring is very critical for the design and the configurations of the system to maintain integrity during its operation. The fire alarm system can be wired with a Class A or a Class B configuration. For Class A system of wiring, it requires a loop in and loop out configuration from the fire alarm control panel via initiating device or notification device. The Class A loop is terminated in the fire alarm control panel across the terminals, positive and negative. Bear in mind, for the Class A configuration, there's two circuits that is occupied since power is supplied from these two circuits to the components. No end-of-line resistors required for a Class A terminal. A Class B configuration are simple and easily configured. However, it doesn't provide a reliable power source to device or devices should a fault occur on the network. A Class B system of wiring is terminated with an end-of-line resistor. Here's a perfect illustration of a Class A network. This depicts how initiating device is connected on the network via a loop-in, loop-out configuration on a Class A network. We can see if there's a fault on the incoming line, it will still be power on the line that is going or coming from the return in. If we have a fault by one of those components or with one of those components, power is still maintained from both sides of the circuits on the Class A system of wiring. Likewise, for the notification circuit, if there's a fault on one side, there will be still power on the other side of the wiring. And where there's a fault with a component, there's power is going to be maintained between two circuits. So this system of wiring makes it much reliable during the operation when there's a fire. The Class B wiring method is pretty much simple and straightforward. However, this method is not as reliable as a Class A method. For this method, we have one circuit being used from the panel. So from one circuit of the panel, it goes to the first device and then we'll loop back to the second and going forward. For the last device, we terminate with an end-of-line resistor. The same wiring method applies also for both initiating device and notification device using the Class B wiring configuration. Modules are modules that are critical for the fire alarm system. The fire alarm module provides an extension to the fire alarm system. Such component is very important for the operation of a fire alarm system. The fire alarm module is addressable in that it can be located within the system, and it is operated from a select line circuits. Just as the initiating circuits, the module is connected across the same circuit. The fire alarm module may require an input power, and in some cases, it may be secondary. The modules are components that incorporates other functions into the fire alarm system. It provides a means of activating or deactivating critical system incorporated in our fire alarm. These systems are air handling unit, fans, damper systems, exit and emergency doors. A fire alarm modules may use to monitor tamper valves, flow switch, and pressure switch. And that is how the fire alarm system uses the module to provide an extension in terms of its function. A fire alarm system module may use to extend the output on the select line circuit for notifiers or initiated devices. Below is a pictorial diagram of a module being utilized on a fire alarm system. Here's a beautiful diagram for fire alarm network of panels. The reason why the panel should be networked is because it allows the communication of the subsystems of the fire alarm on a building that perhaps occupy more than one floors. So by linking the different floors together, once there's a trigger or stimulant of a fire in the building via any device and initiated circuit, all the panel should set in alarm. For the fire alarm system, it is required a certain number of components, and this is important to prevent overloading of our system. Such number can be easily calculated. Once we determine the output from a circuit, the number of devices can be determined by dividing the output by the input or the operating voltage or current for the initiating devices. And based upon the output of the initiated circuit, that number of devices can be determined. A select line circuit or initiated circuit can also be affected where the fire alarm cable is run at a very long distance. Therefore, losses may occur. And these losses on the fire alarm circuit may reduce the number of components that possibly could be added to the network. So bear in mind that your numbers can also determine based upon the losses that occur on the loop. So in determining the number of devices, we should pay attention to losses. Calculation can be done for notifiers. It is very important that we determine the number of notification devices that can be added to a notification circuit via the control panel. The number of notification devices that can be added to a panel is determined by locating the amount of power that is consumed per devices. The number of notification devices that can be added to a panel is also determined based upon the output from the panel for the notification circuit. The notification devices is impacted by the line losses per loop, and if losses such occur where devices is far from the panel, that will affect the number of notification devices that can be added to a loop. A good example is what we highlight here. A notification output where there's like a 24 volts DC voltage operating from the circuit that is producing 3 amps will only allow 60 notifier strobes if each strobes or speaker operated at a voltage rather amperage of 0.05 amps. So the notification devices in its number can determine based upon the output of each notification circuit. Just like calculation is important, we have to take into account the specification requirements for devices and components. A specification points to the selection criteria for a fire alarm system and component. Special consideration must be taken account for the following in determining the component that is required for selection. For specification requirements, device must be selected for operating voltage, operating current, and in the case where we're using a certain panel, we may take into account the output power that is coming from the panel that is fed into devices. We may pay attention to the input voltage for a fire alarm control panel as well. On our right is a perfect example of this specification that we look for. Folks, that's it. Thank you for this wonderful presentation. It was lovely sharing it with you. The next presentation, topic of focus, we'll be speaking to the programming of devices and modules. Also, I want to help you to understand how to set the parameter for a fire alarm control panel. We'll be also going in depth in the different types of module, and we'll be explaining the difference between trouble, supervisory, and alarm signal. Fire alarm systems works with other systems, and it's so important that we'll be explaining how the fire alarm systems is integrated with other critical systems. For more information, please visit the Vigilance Society of Engineers and sign up to join our team of engineers and technical professionals in the field. We are open for more questions and answers in relation to this topic. Thank you.